Alright, today we're going to talk about volume and surface area of 3D solids. So this is kind of a review of what we did in the previous assignment, where we needed to find the length of from this corner of the box to this corner of the box. So using the distance formula or the three-dimensional Pythagorean theorem, I got 6 squared plus 6 squared plus 10.5 squared. Add those together and take the square root, and we get the length from D to F. Now for example 2, we wanted to find the angle between this green line and the base ABCD, which is essentially this flat area space here. So we can set up a triangle from DFB, and here I redrew the triangle. And I could use the 10.5 and the 13.5 here, and that if I did it over here with just those values, I could do, if it's the yellow one and the blue one, this is opposite and hypotenuse. And if I've got the opposite and hypotenuse, I can use sine of 10.5 divided by 13.5, and I get this value. Now I went to all the trouble of calculating the length of dB, this pink line, by using Pythagorean theorem. 6 squared plus 6 squared is 72. Square root of that is 8.485. Using this and the hypotenuse, I could use cosine and still get the same answer, 51.1. The next one says find the angle between DF and side DCGH, and I redrew, shaded it so you could see DCGH better. And what I've got here, I've got the line DF here, and this green space is that base. And so if this is the base I'm working with, then one of the side on the base is DG, and the other side of this triangle is GF. And we already know GF is 6, and we know the blue line is 13.5. And so if I'm trying to figure out this angle here, HDF, then I'm going to be using the 6 and the 13.5, so which is the opposite and the hypotenuse. And if I'm dealing with opposite and hypotenuse, I'm going to use sine. So 6 over the hypotenuse. Okay? Alright, you may want to hit pause and copy this down. Alright, next question. Okay, if we're finding volume of any old prism, we need to find the area of the base times the height. So the base area, I use capital B for area of a base. The area of this base is 6 times 4, and this height is 1. So we end up with 6 times 4 times 1, which gets me 24 meters cubed. The units is very important. The area of this triangle here is 12 centimeters squared. So multiply that by 7.5. This gets me the volume of this triangular prism. Here we have another triangular prism, but it's fallen on its side, go boom. Okay, so the area of this base of the pink triangle is 1/2 1.5 times 10. So the area of the pink triangle is 7.5 centimeters squared. And then the volume is that base times the height, which is 8 centimeters, and we get 60 centimeters cubed. You can always hit pause and replay to see this again. Alright, so now we have a box. There's the bottom and top, which is 6 times 4, which is 24. Then we also have the left and the right side, which is 6 times 1. 6 times 1, we're going to have the left and right side with an area of 6. And then there's the front and the back. And the area of the front is 4 times 1, and the back is 4 times 1, so we have those areas of 4 times 1 there. So if we add all 6 sides together, we're going to get 6 plus 6 plus 24 plus 24 plus 4 plus 4, and that adds up to a total surface area of 68 meters squared. Okay, next one. Okay, calculate the volume of the cylinder with a radius of 2 centimeters and a height of 7.5 centimeters. So the base here is a circle, which the area of that is pi r squared times the height. That gives us the volume of our cylinder. We know the radius is 2, so I've put in the 2 there. We know the height is 7.5. So now we have pi times 2 squared, so we've got 4 pi times 7.5, and then we simplify that and we get 94.2 centimeters cubed. All right, so now we've got a lake. And the lake, the area on the surface of the lake is 85,000 meters squared. It's a big lake. Okay, and the average depth of the lake is 28 meters. Estimate the volume. Okay, so we've got our base area of 85,000 meters, and the depth of the lake is 28. So you multiply those together, you get your volume. So now this one here, practice 3, we've got a triangular bottom, and it's not a right triangle, and then we have a height of 15. So what we did was we found the area of this base, and we used our area formula, 1/2 AB sine C. And basically how that works is we've got our triangle, and C, angle C, is on either side of the it's the included angle in between the sides that we know, the A and the B. Okay, these sides are on either side of the angle that we know. Okay, and so we're going to follow that formula. So these sides of 12 and 12 are on either side of the angle 130, and we end up with 55.155 for the area of this triangle part. Okay, and then we have our height of 15 centimeters squared, and multiply those together, and we get our volume. And 3 significant figures, it's 827. You may want to hit pause to copy this down. Next. Okay, so now we've got a swimming pool with the dimensions shown, and the cost to fill the pool is $1.50 per cubic meter of water. So once again, our base is 7 times 4, and our height is 3. So the volume here is 84 meters cubed. Okay, now using the cost here, we know that this is $1.50 cubic meters of water. So we have $1.50 per meters cubed, and if you set up the ratio right, because it's dollars per cubic meter, the meters cubed in the numerator and the meters cubed in the denominator cancel out, and then we're only left with dollars. This cancellation of the units is called dimensional analysis. Okay, let's look at practice number 5. So this whole length is 3, this height here of this triangle is 6, so the base area of this triangle is 1/2 base times height to get me the area of the triangle. And then the height of this triangular prism is 10.4. Okay. Then we end up with a volume of 93.6 centimeters cubed. Now they've told us the mass, they've told us the density is 0.71 grams per centimeters cubed. Using the units of measure really help you decide, am I supposed to multiply or divide by this value? Since it's grams per centimeters cubed, I can write it as grams over centimeters cubed. The centimeters cubed here cancel out, and then we multiply those together and we're left with grams. Okay. Question number 6. We've got a cylinder here with these dimensions. The cylinder is going to get melted down into 2 centimeters cubed. Okay, how many cubes are we going to make? So we've got our volume, which is the base times the height. So we've got pi r squared, so pi times 3.2 squared times the height of 8.5, and we get 273.444. Okay. Now, from this other information, the cylinder is melted into 2 centimeters cubes. So if it's a 2 centimeter side of a cube, the cube is going to have a volume of 8 centimeters cubed. Okay, so now to find out how many cubes I'm going to come up with, I take this volume, which is 273 centimeters cubed, divided by the size of 1 cubed. Our centimeters cubed cancels out, and we're going to get the number of cubes that this is going to get melted down into. You may want to hit pause and play this again. Alright, calculate the volume of each solid. So once again, our formulas for the volume of a right-hand cone is 1/3 pi r squared times the height. Oh, it's a rectangular pyramid. So 1/3 area of the base times the height. So the base area is 4 times 3.5, and the height of our pyramid is 7.4, and since it's a pyramid, we're going to multiply it times 1/3, and then we get our volume. Okay, now this one here, same sort of thing. Now we don't know the height. We have to figure out our height. So in order to figure out the height, I used Pythagorean Theorem. So we got 3.2 squared times h squared is going to equal the hypotenuse of 11.5 squared. So I can rearrange this to solve for h squared. So we subtract 3.2 squared on each side. Then I take the square root of both things to solve for h, and then we end up with the height being 11.04. Okay, so this is our height. So now we know our base, it's a circle, so it's going to be pi r squared, so pi times 3.2 squared, and since it's a cone, we multiply it by 1/3, and then there's our volume. You may want to hit pause to copy this down. Okay. A cylinder can holds 3 tennis balls. Each ball has a diameter of 6 centimeters and the same diameter of the cylinder, and the cylinder is filled to the very tippy top. Calculate the volume of the space in the cylinder not taken up by the tennis balls. Okay, so first I need to figure out the volume of a sphere. So the volume of the sphere uses this formula, which is 4/3 pi r cubed. So I've got 4/3 pi 3 cubed because our radius is 3. And then I get this value here. Now I need to figure out the volume of the cylinder. Now if the diameter is 6, that means from here to here it's going to be 6, right? So if this is 6, I have 6 plus 6 plus 6, so the height of my cylinder is 18. Now the radius of the cylinder is still 3. So pi r squared times the height is going to give me the volume of the cylinder. This is my base, pi r squared, and then we've got our height of 18. So pi times 3 times 3 times 18 is going to give me this value. So now the volume of the empty space is the volume of the cylinder minus the volume of 3 of these spheres. So 3 times the value of one sphere gives me the value of all of the tennis balls added together. And then the volume of the cylinder minus the volume of all the spheres added together gives me this value. 3 significant figures. The 6 rounds the 9 up to so we have 70 here. Okay, question number 8. Find the total surface area of the rectangular base pyramid whose base has the dimensions 10 by 8 and where the slant heights are 12 and 13 respectively. So this picture was a little bit misleading the way it was drawn. Which is why I crossed this 10 meters out and that there, because the 10 meters goes from here to here and 8 goes from there to there. So I drew the net first to help me figure this out. So we've got 2 triangles sides and another 2 triangle sides that are we're going to be adding all these together. So this triangle side with a slant height of 12 has a width of 10. So I can figure out that this triangle here, this yellow one, is going to give me 60 meters squared. This other side triangle has a height of 13 and a width of 8. So 13 and 8 and 1/2. This triangle is going to give me 52 meters squared. And then my base rectangle here is 8 times 10. So the area of that base is going to be 80 meters squared. So I'm going to add the 60 plus 60 plus 52 plus 52 plus 80, and then I get a total surface area of 304. Okay, now we've got a cone. It's got a radius of 5 centimeters and a total surface area of 300 centimeters squared. So if I'm trying to find the slant height, here's the formula. So the curved surface area of a cone has the slant height with a script L, and the curved surface area is pi RL, and this area here of the circle is pi r squared. So the total surface area is equal to pi RL plus pi r squared. Well, we know the radius is 5, and we know the total surface area is 300, so now my only variable is L. So pi times 25 gives me this. I subtract 78.5 on both sides. I get 221.46 equals 15.7. Divide both sides by 15.7, and we get this value for the slant height. Now that I know the slant height is 14.1, I can calculate the height using Pythagorean Theorem. So I can say 5 squared plus h squared equals 14.1 squared. We can subtract 25 on both sides. So 14.1 squared minus 25 squared gives me this value. Take the square root. Almost done here. Okay. Silo has a cylinder, part of a roof that is a hemisphere. The radius of the cylinder is 3. The height is 12. So to figure this out, we have half of a sphere, and we also have the volume of the cylinder. So the volume of a sphere is 4/3 pi r cubed. So we've got 4/3 pi r cubed, and since it's half of that, we've got to multiply 1/2 since it's half of a sphere. And then the volume of the cylinder is base times height. Our base is pi r squared because the base of the cylinder is a circle. So these values gives me 18 pi. These values multiplied together gives me 108 pi. Add those together, we get 126 pi, which simplifies to 396 meters cubed. Question B. The entire silo is going to get painted. How much paint is needed if 1 liter covers this amount? Okay, so we have, once again, we have half of a sphere, and then we need the lateral area of the cylinder. This might have been where you struggled, possibly. So the lateral area is the rectangular part of a cylinder. And so this length of the rectangular part right here is going to be 2 pi r, because that is the circumference around a circle. And then we have the height of our cylinder. So we know the height of the cylinder is 12, and the circumference around the cylinder is going to be 2 pi r, and we know the radius is 3 meters, so it's going to be 2 times pi times 3, which is the circumference around the cylinder, and then the height of 12. So then that gives me 72 pi, which is the lateral area around the cylinder, and add these two together and we get the total surface area. Now to figure out the amount of paint, we take the surface area and we divide it by 8.5 meters squared. The meters squared cancels out on the top and bottom, and now we're left with liters. So 33.2 liters of paint. So we're going to need 34 cans of paint to do this. Last question. Okay, you may want to hit pause to copy this down. Okay, find the volume of the toy. So we've got a cone, and we've got the volume of half of a sphere. So the volume of a cone is 1/3 pi r squared times the height. The radius is 4, the height is 10. This is the volume of the cone. The volume of the sphere is 4/3 pi r cubed. We know the radius is 3. And we've got half of a sphere, that's why it's half. And then we add these together, simplify, and we get 302 centimeters cubed. Okay, find the slant height of the toy. So I know the height here is 10. I know the radius is 4. Slant height, we can use Pythagorean Theorem. 10 squared plus 4 squared equals slant height squared. So the slant height is going to be the square root of 116. Okay, final question. Find the surface area of the toy. So we've got the side of the cone plus 1/2 of the sphere. So the side of the cone is pi rl, and the formula for the surface area of a sphere is 4 pi r squared, so which we can get the formula from here. So surface area of a sphere is that, and the area of the curved surface of the cone is this. So once again, use your formula sheet to get your formulas. So we plugged in 4 in for the radius, 10.1 in for the slant height, and then we simplified, and then we end up with the total surface area being 236 centimeters squared.